myself, Rajesh, Assistant Professor, College of Engineering, Muttatara. I welcome all of you to the session, and this current session is conducted by Sri Ajith Gopi. Ajith Gopi is an additional Chief Technical Manager at the Agency for New and Renewable Energy Resources and Technology, Department of Power, Government of Kerala, and serves as a chair of IEEE Power and Energy Society Kerala chapter. He leads the initiative in solar PV consultancy, floating solar and solar wind hybrid power plants. So I heartily welcome Dr. Ajith Gopi to the session. So sir, kindly please start the session. Thank you.
Green energy solutions building a sustainable carbon neutral world. Very relevant topic. I'm thankful to the whole team. I'm thankful to College of Engineering Muttatara. Without much introduction, I will start my presentation. I will share my presentation now. So very relevant topic, I would say that solar and wind energy solutions fueling the green revolution. So this is adding to your green energy solutions, FDP. It's very important. If you look at Kerala, we have abundant solar energy because of our geographical situation. We are close to the equator, a very sunny region, and naturally we have very good wind energy as well. So both solar and wind majorly contribute to the renewable energy prospects of Kerala, I could say like that. So my talk, or maybe a discussion, will be based upon these two technologies, based upon the topic. In between, you can interpret and ask questions, intervene and ask questions. And also, end of the session also we will have. So I plan to speak about 45 minutes to 1 hour. Then we will have a Q&A. So we will have a discussion, or maybe my kind of deliberations in the beginning, maybe 45 minutes to 1 hour. Then fine, then we will have a Q&A. So I can answer your questions and general doubts and all. Thank you so much again. So the picture I have given here is a 200 kilowatt rooftop solar plant at the third phase of Technopark, which is near to your engineering college. Yeah, it is approachable from the highway bypass. So you could see the third phase building on the rooftop. We have 100 kilowatt and 100 kilowatt. I only installed it on behalf of ANERT as part of my consultancy project. They approached us for a rooftop solution, a mid-size rooftop. It's a 200 kilowatt, 100 plus 100. So I'm giving this explanation is because it is very easy to go with a solar rooftop power plant at every rooftop if the rooftop space is available without much shade. Only thing is, it is near to the seaside. This is actually near to the sea. You have to be a bit careful. You should have marine compliant specifications, technical specifications for your equipment, PV module, especially the structures and all. PV module will have the salt mist corrosion resistant certification. So this is very important. When we look at the specifications of the general specifications, we look at the salt mist corrosion specification as well when we go for erecting a solar plant at Muttatara Engineering College as well, because it's near to the sea. So this actually serves their needs a little bit. In fact, the Technopark is having a huge requirement of power, but because of it's a DISCOM. Technopark itself is a discom, so they have some obligation, RPO, renewable energy purchase obligation, to have some percent of their energy production should have the solar, should have the energy generation from solar energy. Okay. So coming to the context, or setting the context, I should say that in that way. See, look at what happened the previous year, May 2 of 2024. The state recorded a very, the peak consumption of 114 million units in Kerala. Most of you know about it as electrical engineers and other engineers. So the peak demand was about 5,500 megawatts. So it raised the question, how long we can stand with this? So can we contain this, or whether this will repeat again? So I predict that this will repeat again. The record will go high and high again. And I believe that this can happen in any month because of the type of consumption we have. Predominantly, the consumption was because of the powerful ACs fitted in our households. So people are turning to ACs, different from our earlier behavior, or our way of sleeping in the night without AC was common, but people are switching to AC now. Second reason, major reason, was can anyone update me what may be the next reason? Please, let it be interactive. A major consumption happening in Kerala. New style
of charging vehicles.
Yes, absolutely. The EV charging. So that is well said. So this is happening without much planning, I would say, because by 2023 itself, it was more than 180 lakhs of registration as per the RTO. It's going like anything. I'm not sure that we do have the infrastructure. ANERT is making a lot of infrastructure for charging facilities. KCB is also doing that. I don't know, it is in a planned way, but it should be in a planned way. I think ANERT and KCB seriously considering to make it a special geospatial assessment before doing it. So ANERT is actually seriously looking at it. So we have to have a plan, like how is the concentration of your EVs and how you are locating your charging stations. It's very important that how the priority is fixed. So it is affecting us actually. And of course, the infrastructure, the grid infrastructure, whether the grid infrastructure is capable of handling all this. So in fact, what happened in April and May, I think you people know about it. Hundreds of transformers burned because of the overload and all. So we have to look at alternate sources. So alternate sources are coming as well. See, look at the latest statistics from MNRE site. Actually, this has been filed by KCB. This is from the Ministry of New and Renewable Energy. The KCB has updated this. The total rooftop solar reached almost 1,000 megawatts. So might have reached 1,000 megawatt as of now. And ground mounted, it's not going much actually. You know, there are a lot of difficulties in switching or maybe installing ground mounted solar plants. So 320, I've been seeing this figure for the last 1 year. So there is no much, at least for the last 6 months, it's almost 320. But I won't believe that 320 is the only possible way in Kerala. You have a lot of wasteland where you can go for ground mounted solar. I'm not speaking about the floating solar. It is another very good option that I will come back. So ground-mounted solar is going. It can go a lot, or maybe much greater extent in wastelands, in abandoned quarry lands, in areas where agriculture is not possible. We cannot go for converting the agricultural land into the solar farms. But of course, the coexistence of solar farms and agriculture is there because of the new way of agri-photovoltaics coming up. Most of you know about it. Internationally, a lot of projects coming up in agri-photovoltaics. In India also coming up. ANERT also, like we had some agri-photovoltaic project, a pilot project in Palakkad. So more than 1,300 megawatt is coming from solar, which was not a we never thought that this solar will contribute this much, especially the rooftop solar. I would say that because of the democratization of the solar rooftop power plants, you may be knowing about the PM Surya Ghar program. The PM Surya Ghar program is a program by Government of India where there is subsidy for the rooftop sector. So it up to 78,000 rupees per maximum subsidy. You will get up to 3 kilowatt. Then the subsidy is, there is a cap. After that, you will get 78,000 only. So 30,000 per kilowatt. 2 kilowatt, you will get 60,000, and 78,000 for 3 kilowatt. So above that, you will get the same subsidy. So this has been taken up in various states, and Kerala leads. Kerala is only second to Gujarat on this. If you look at the quality, Kerala's installations are very good. So the PM Surya Ghar, the response to the applications, there is a portal for that. The response to the application, the installations, and overall monitoring, Kerala is leading actually, and Kerala is second in terms of the total installations. So I'm telling the statistics to get you updated on what exactly happening. So if you look at the installed capacity of Kerala, it comes about 3,000 megawatt, as all of you know, or around 3,600 megawatt. But PV comes a major contributor for that. We never thought like that in 2010. So 70% of the power is coming from the central grid, up to 70%. And usually during the summer, we are purchasing more power, 30% only, and predominantly 30% is from the hydroelectric power plants. So if we think about how we can solve this, the issue happening in Kerala, because 70% of power is being imported, and we are depending on the central resources. If there is war or some sort of emergency or issue, then, or maybe it happened sometimes that the buffer stock of coal became stagnant, or they were not supplying for some time, for 2-3 days at least. I think a couple of years back. So it can happen at any point of time. So this is a reality, and we have to look at our resources. So we have plenty resources. That's what this slide defines. So according to the Meteonom data is nothing but it's a satellite data, a private satellite data. It is purchasable. You can get it's more accurate. You will give a more degree of accuracy when compared to the NASA data. I know that a lot of research scholars are sitting here, attending this. Faculty are professors are attending it. So as far as research scholars are concerned, if you need a more accuracy data to get solar energy, we have to look at more private data. So this is an example. Meteonom, you have to purchase it. So once you pin your coordinates, you will get the data up to 8 square meter accuracy. And NASA will have a 50 kilometer grid. That means 50 square kilometer grid. So 50 square kilometer grid is something different. So we should have a more precise resource to get a data. So Meteonome is one of the data, which is private data. Like that, a lot of data is available. In Europe and all, PVGIS is one of the data. Then I think there are other data like solar GIS, PVGIS, HelioClim. A lot of data is available, which are some of them are private, some of them are open, some of them are available in Europe only, some of them are available in US. And the installed capacity in India as of now in December, so it's 2024. Please correct it, 2024. It's about 90 or more. It's reaching. It's 31st December 2024. It's not correct. So this is the latest data. You can see that the renewables, especially wind power and solar power, where my topic is based upon, is covering the major portion of renewable energy power, other than the large hydro. And small hydro is considered as a renewable energy source, and wind power and solar power predominantly covers the other than large hydro, and it's almost 100 gigawatts for solar and almost 50 gigawatt for wind. So if you look at Kerala, 1,300 megawatts. So please compare this. 1,300 megawatts. So it will be 1.3 gigawatts. So solar here it is 100 gigawatts. In Kerala it is 1.3 gigawatts. It is not good as compared to our neighboring states. Tamil Nadu and Karnataka is going in a very high speed. Wind power also, like we have 71.875 megawatts, 275 megawatts, 71.275 megawatt against 48,000 megawatt of the total installed capacity in India. So solar is actually a lot of things are happening in solar. More than 30% of our energy needs are met from renewable energy, and a lot of countries are reaping these benefits. 64% of Denmark consumption is from solar. And if you look at South Australia, at some point you could see more than 100% happens. More than 100% of solar, their needs met at some point of time from solar. So, one second. Yeah, 101.7% of South Australia's energy needs. Why this is happening? Because of their, see, even the first time rooftop solar exceeded total demand in any region. So rooftop solar is an intermittent way of resource. So a lot of researchers attending this will be looking at the intermittency of renewable power. Am I right? So intermittent, solar and wind are intermittent because it depends upon our nature. It's completely intermittent. Solar is actually when cloud comes, your solar energy will be decreased. The energy production will be decreased. But still, I would say that more than 20 million generated for the last 8 years from the 2 megawatt plant at Kudalmannam we installed. So solar is definitely contributing a lot. And wind, of course, it's also seasonal. If you look at India or Kerala, we are depending much on the southwest wind power. The monsoon period is the southwest monsoon, and I think one more season is there. The one season is from June to October, June to August. Then another starts from September. So these 2 seasons actually we have very high wind speed as well. I have some slides showing that. So we have to tap this time only, and there are areas where you have higher wind speed. There are limited areas, which I am also showing some of the slides. And I'm coming to the area that it's intermittent. So how you make a base load? There are methods where this intermittent the resources can be managed. You have intelligence. You should have intelligent solutions to manage it. You should have a excellent forecasting system to take the whole rooftop power. Rooftop is actually can add more power to our Kerala power energy mix. Of course, you need an intelligent forecasting system of what exactly it can come from the present conditions of the weather. So it's possible now. It's happening. And wind, there is an excellent system available up to 2% to 3% accuracy. It is predicting. Solar also the same prediction is happening. So excellent forecasting system with very good local level management of the grid. We know that we have the SLDC, the load dispatch center. So load dispatch centers or the load governor or maybe the controlling area or controlling system of the local utility should be excellent to manage it. At the same time, you can have the virtual solar power, virtual power plants, VPPs in place, where you combine different resources and different loads together. You will have solar, you will have wind, you will have battery, battery energy storage systems. So all combined together, and you have different kind of loads. So all you convert into a single entity. For example, Ponmudi is a region where you have excellent wind. So Ponmudi, if you are having some 2-3 wind turbines there, so we have wind resource, and solar is also available because it's an area where you will get at least 4 kilowatt-hour per meter square, or maybe 4 sun peak hours of energy per day, 4 kilowatt-hour per meter square per day. And solar is available, of course, seasonally. And if you provide a battery energy storage system there, thus, and if you power that the complete system using battery, solar, and wind of different specific load, there are different government organizations there. So if you combine all these systems together in a single entity and utilize and control it from a computer, it's possible. It's actually, in another way, we call it as a virtual power plant. A virtual power plant, the concept is a single entity. It can be controlled with a single entity where you have different resources and different loads, but controllable from a single entity. So with I'm repeating, with energy forecasting, with very good local level energy management or load dispatch centers, more decentralized and more specific, with virtual power plants or VPPs in place, it's easier to manage your intermittent resources, solar and wind. It's happening in developing world, and it's happening in South Australia, it's happening in Denmark, it's happening in Germany. Of course, we have an advantage. The advantage is we have a lot of resource from the hydroelectric stations. We have, if you take a hydroelectric station, you have individual generators in place where you can switch off or shut down on generator during the day when a floating power plant generates. So that way you can keep that water there. So if you have floating solar power plant at TDG reservoir, and you have the 780 megawatt of installed capacity, and if you shut down one of the generators or 2 generators to keep that water during the day, at the same time, the floating solar power plant proposed to install in the reservoir dam can generate. I'm just giving a guess only, or it's an idealistic situation. Can pump the power to the grid using the same evacuation facility or maybe an upgraded facility. So that is the way that we can have a system, and of course you can incorporate BESS into it, battery energy storage system into it. So BESS can keep the power, excess power what you generated during the day from a floating solar power plant into it and utilize it later. So before switching to wind, I will introduce the latest emerging technology, PV technologies, which will be good for you to update. I think you people know it, but let me know if you have to skip it or not. Okay. The first generation crystalline silicon is you know about it, monocrystalline and polycrystalline. This is a polycrystalline installation at Kerala University. There is an engineering college there. There I installed it as a deposit program 8-9 years back. It was a 100 kilowatt plant. So generally crystalline plants will be monocrystalline and polycrystalline plants. So which is more common or common in the market? Can anyone reply to my question? Which is more common or popularly available in the market now? Can anyone come up? I would like to hear from you.
It's monocrystalline.
Yes, absolutely right. May I know who is responding, sir?
Myself, Rajesh. Sir.
Okay. Rajesh from Muttathur Engineering, right?
Yes.
Okay. Absolutely correct, Rajesh. Monocrystalline is now ruling the market. It was not the case before 2000, I would say 2014. So when I joined ANERT back in 1990, we were installing projects with the monocrystalline. I remember I installed a 35 watt, systems with the 35 watt PV module, 35 watts. The STC rate, standard test condition rate was 35 watt only. Now you are getting around 700 watt peak PV modules. That time in 90s, it was 35 watt only, costing to around 300 rupees per watt peak. 300 to 350 rupees per watt peak. So now the cost has come down to 17 rupees per watt peak. So 300 rupees to 17 rupees per watt peak, the change. And we were installing solar power plants with the monocrystalline plants at that point of time because the efficiency was something around, I remember it was 10 or less than 12. I installed back in 1990 on one off-grid project at Chegadi near Pakam tribal settlement. I was a project engineer there. So we were getting only monocrystalline panels at that point. Only the peak wattage was, the total capacity was only 35 watt per PV module. Now you are getting a 700 watt PV module, or maybe a couple of 700 watt will give you 1.5 kilowatt solar panels. So only 2 panels needed for 1.5 capacity. And up to 2004, then there was suddenly the market changed to polycrystalline from 2000 onwards. So initially in 90s, it was completely monocrystalline, up to 12% efficiency. Then the market completely changed to polycrystalline, around 14% efficient, or at that point of time. And at the same time, the monocrystalline efficiency increased to 18,000, maybe something like that. Initial period, it was not like that. At 2014, I would say that it was around 18% or 19%. So at 15% or to 16%, you will be getting polycrystalline PV modules. It was easier because, the ingot, you are getting the crystalline ingot. You don't need a single crystal. You can utilize a lot of multi-crystalline cells embedded into this, so it was cheap. Now again, after 2014 or 15, the market regained its monopoly, as Professor Rajesh was telling. Monocrystalline is coming, but a lot of improvement happening. And the second generation, of course, the thin film. A lot of thin film PV modules are there. Cadmium telluride is one of it, which is promoted by the First Solar, a US-based corporation. There are installations in Gujarat of cadmium telluride. I was also involved in some of the installations when I took leave from ANERT. Copper MgM, gallium cyanide, selenide, and gallium arsenide. These are some of the thin film, but your efficiency is up to cadmium telluride, you will get efficiency up to 12-13%, or lesser than that. Or if you look at amorphous solar, it will be up to 7%. But these thin film do have some. This picture is from ANERT installation. This do have some peculiarity. It can generate more based on the studies done by MNRE of your performance assessment. As research scholars, you will be looking at the performance resource assessments of this solar PV module types. If you even compare with the different technologies, it would have been a paper 10 years back. Now the new things are coming up. So, but still, if you add more additions to the manuscript, value additions, you can have more novel papers. The novelty of your paper can be added, of course. And there are innovations happening, which is half-cut is one of the innovations which optimizes the space. Of course, the wiring will be different. You have half-cut PV modules a lot. You don't have space in between, which reduces the potentially induced degradation, PID. Potentially induced degradations were there in 2014, 15, 16, even 17 time PV modules, mostly P-type PV modules, where you have spaces in between the PV cells, where a lot of EMF will be induced into the surrounding areas, which actually makes some reduction of current, or the current will be some losses is happening. Okay, so which can be updated with the half cut. You don't have much space in between. And PERC, passive emitter rear cell or contact, which is known to all of you. If you look at some of the PV, can anyone come up? Where do you have any solar power plants available at your rooftop? I think Muttakara is on having, right?
Yes, sir.
What is the capacity actually?
Around 60
kilowatts. It can be, if it is very near, maybe installed 2 years back. Within 2 years, it should be a PERC, mono PERC module. So it will be a monocrystalline PV module because recently you have only monocrystalline PV. PERC will be passivated emitter rear cell, which we can see the comparison. You have extra, there is a reflection coming up, so you will get extra generation because of the reflections. You will add more light into the PN junction. So this extra provision is because of the passivated layer on the rear side. So it's called a PERC. So if you ask for any manufacturer, any rooftop guy, you have 1,000 manufacturers, EPC companies in Kerala. That is a real challenge to pick. You have 1,000. I don't know these 1,000 EPCs up to 1,000. 700 are really working on the PM Surya Ghar program. So the important thing is whether these people will be there after 5 years. That is very important. So that is a very important thing, that a lot of PV EPC companies are emerging. So you have to evaluate their the basic strength and all. So, but any EPC player will be offering you PERC, mono PERC, because mono PERC is available in the market most commonly. And bifacial, I have seen a lot of queries from some of the my friends has forwarded some in WhatsApp some of the specifications they are proposed, some private installations. So a lot of the EPC companies are offering bifacial for rooftop. Is it beneficiary? Is it beneficial? Definitely beneficial. You have 10% extra generation, but in rooftop power plants, personally, I'm not supporting it. Bifacial can be there for a large rooftop, and provided you have a most reflective space on the below, because you have both phases will generate. So if you have a white color painted on the ground or on the rooftop, you will get extra generation to 10% extra. But generally, I would recommend a bifacial for a small 3 kilowatt rooftop. So some of these beneficiaries have forwarded this to me, just asking this question. So all this, maybe because of this bifacial is surplus in the market and people are dumping it. Because bifacial, a lot of people, so they are just giving bifacial to the customers. So I personally suggested bifacial is not needed for a 3 kilowatt, 5 kilowatt plan. Of course, for the academic purpose, I do recommend. You can have a comparison of your monofacial and bifacial. Okay. And heterojunction is a technology where you have up to 28% of efficiency, where you blend together 2-3 technologies. Generally, I've seen a plant. I worked in Gujarat when I took leave in 2011, 10 to 13. So at Gujarat Solar Park Charanka, we worked for a 25 megawatt plant where they used the heterojunction PV modules. It was an amorphous silicon single crystalline heterojunction plant. So heterojunction plants will have a combination of 2 or 3 different technologies together. Okay, just to give you an idea about that. But it's giving very good output. TOPCon is the reason one. So other than PERC, mono PERC, passive emitter rear cell, TOPCon is coming into picture. And most of the TOPCon PV modules are belongs to N-type. So you have P-type and N-type. The predominant, if it is more thicker, then you call it as N-type. In PN junction, N junction, N. If it is more thicker, then you call it as N-type. Otherwise, it is P-type. So here the advantage is N-type is phosphorus doped. The boron, if you go for boron, there is a degradation chance of oxygen. If oxygen is there, it can go to oxidation and all. So phosphorus doping adds free electrons also. So TOPCon will have layers on top and back. The other PERC will have only a rear side, the passivation layer. You have different kind of chemistry to add your generation on top and bottom. So that is TOPCon, which is also available in the market. A lot of manufacturers now offering. Okay, that was about the technology. I will quickly go through, because of the time limit, go through some of the other solutions. See, you know about the large solar power plants. This I was speaking about the 2 megawatt plant. I only led the installation. Though this is a 2 megawatt plant at Kuralmandam, it's more than on 31st December. I would say that 20 million units. 20 million units means 20 into 10 lakhs units fed to KCB, and we earned a revenue of more than, I think, 5 to 6 crores, if I am correct. So there is a PPA with the KCB, and we are the independent. This is the first solar IPP project. IPP means Independent Power Producer Project. First IPP project commissioned in 2016, and the COD, the commercial date of opening, was actually 2016 December 19. So you can see the control, the control center, or the main area where the inverter is. Control room is here. This is at Kudalmannam, very near to Palakkad, 12-15. So a lot of research, what you call, the students are visiting there from engineering colleges. We are arranging visits here as part of their IV and all. A lot of IEEE student team also visiting. So I will explain it. It's a plant with at that time the polycrystalline solar PV module. So I have a special arrangement there. The special arrangement is we have a rooftop plant as well, a 10 kilowatt plant, which looks at the auxiliary power. And I have a setup for measuring the atmospheric data, a solar radiation resource assessment station, which is peculiar to this particular plant. Generally, it won't be there. Where we have a solar tower is here. You can see the solar tower here. So your solar tower, we have a pyranometer, which measures the GHI, global horizontal irradiation. And I have a shaded pyranometer, which measures the diffused horizontal irradiation, DHI. And I have a pyrheliometer. You can see this here, which measures the direct normal irradiation, DNI. So I was referring to some certain differentiate, some what you call terms of your radiation. GHI is global horizontal irradiation. DHI is diffused horizontal radiation. Of course, the name sounds like it is reflected from clouds and all. That is diffused. And you have a direct number which is directly hitting from the sun. So there's this is a tracker actually. This, you can see the tracker here. This tracks the sun to hit it here. So you will get a DNI, direct normal irradiation here. And of course you have a Internet of Things, what you call a kind of arrangements here, a highway, a modem which transmits a data logger, a modem which transmits the total data to the headquarters here. So you have an ultrasonic anemometer which measures the wind speed, and you have rain gauge for measuring the wind. So this is an experimental setup. So if you look at the performance of your solar plant, there are various measures you can do as researchers. So the 2 megawatt plant will have is having 7,704 PV modules, 260 watt peak. At that time, 260 watt peak was the highest capacity 8 years back. You have a tilt angle of 12 degree. You have two numbers of 1 megawatt Hitachi. It never failed because we have an IMC, annual maintenance contract, and we are evacuating to the local grid there, not to the substation. You could see some pictures which from the Google map and all. You can see the schematic here, not pure SLD. I would say that we have a road going this way, which divides this solar array into two, 1 megawatt here, 1 megawatt here. We have 1 megawatt inverter here, 1 megawatt inverter here, and you have a 2.5 MVA transformer where you have two primaries and one secondary, and which the inverter, the transformer makes the voltage up to 11 kV to evacuate from 300 volt. Okay, and if you look at the performance of your plant, it's very important as far as a researcher is concerned. IEC 61724 defines your. My PhD was based upon IEC 61724. I was studying a lot on the performance of large-scale solar power plants in tropical region. So I basically depend upon IEC 6M724 specifications for my research work. And by my publications, my research publications, all completely depend upon which are published in QN journals, but it's all based upon the performance of utility scale power plants in interaction with the weather, atmospheric conditions, etc. So this dip, you can see there is a dip here. Why this dip is coming? Can anyone tell this?
It's a rainy season, sir.
Absolutely, absolutely. It's a rainy season, June, July, August. So rain actually affects. See, one paper I published in 2021. It's there in my Google Scholar. Part of my PhD work was it's completely about how the rain affects our the tropical region solar power plants. So I found around 25 to 34% of dip. But that was a research interest I made from research finding I found from my research. But later, after 4 years, 3 years, Elsevier has took that as one of the papers which contributed to the much what you call the threat we are facing, the humanity is facing because of the climate change and global warming. So they collected papers which mitigates the papers which mitigates how, or maybe which addresses these kind of things, which gives knowledge to these things. So a solar power plant in tropical region can dip up to 30% or 25 to 34% of generation because of rain. That is a reality actually. Of course, we have summer season, but of course, this is compared to the dry area, you have a dip because of the tropical regions. So I got a recognition from Elsevier for that actually. So it's very important that if you try to have an idea of, to look at various aspects of your generation and how it interacts with the atmospheric conditions, you will get a lot of results. You can see the dip here as well. Okay. And coming to a microgrid at Ponmudi, recently installed on behalf of ANERT, by me only. So it's a wind solar hybridization. We have a vertical wind turbine here. So this is another solution. We have two projects here. One is a 12 kilowatt solar wind hybrid system where you have a solar PV hybrid. Your inverters are hybrid inverters here. So I have three numbers of 4 kilowatt Studer inverters, which makes us a separate system here, feeding to the street lights, around 40 street lights. And this actually caters the need of the area where the canteen is there in the Ponmudi Golden Peak restaurant or resort. The vertical wind speed is not performing as I expected actually. It's not contributing much as I expected. A lot of issues with the wind as well. But PV, of course, is definitely having the advantage. And of course, I provided battery there with because it's all hybrid off-grid projects. Off-grid, and this is completely off-grid, wind solar. Completely off-grid. This is hybrid, where you have a grid connection as well. You can connect it to the grid and feeding the power as well. So this here it is feeding to the power to the grid, and of course in critical time when the grid is not there, it can island and feed the power. So it has an anti-islanding system in place. This is Homer Pro. Some of you might have done, some of the researchers might have worked on Homer. Homer is an excellent software. You can. This is based upon a paper I published in IEEE. Part of an IEEE conference it's available in IEEE platform. So this you can Homer software you can utilize for hybrid, especially designing hybrid solar power plants, where you can separately measure wind and solar. You can configure it based upon your needs. You can add your storage battery. You can add your aero generator, means wind turbine, and you can configure your load and get the pick the components from the software, and you can get the results. You can see that results, how the results comes. You can see that wind contribute PV, even though wind is pretty good, wind speed is there, and wind energy is there in Ponmudi. The predominant the resources from solar, because its wind is very windy, wind is seasonal. So wind we have to understand it's only seasonal. So you can just see the percentage of contribution. Small wind is contributing only 30%, and wind is contributing based on the simulations from the Homer software. It's another way of looking at it. You have the LCOE also, levelized cost of energy, as we renewable energy professionals speak on the what you are in terms of the price cost. So LCOE is levelized cost of energy, which is which is measured actually the total. It's a ratio of the actual cost and plus actual installation cost plus overhead cost for the design period. For example, 25 years. Brought that total cost to the present. What you call it? We make it to the present cost divided by the total generation. So actual cost, the installation cost plus O&M cost, brought it to the present cost divided by the total generation will give you the LCOE, which is a measure of the actual what you call attraction of your resource. If you look at wind, it will be around more than 4 or 5. Solar, it was 15 when it was around, it's more than that, and 8 years back it was around 5, 6 when I commissioned the 2 megawatt plant. Now it is less than 3. So LCOE, once it is lesser and lesser, it's more attractive. You can see wind is making a higher LCOE and solar is making a lower LCOE. It's a factor very important. So you are getting lower LCOE, it is more attractive. Okay, and these are the solutions which the PV has been utilized. You have ground mounted, you have floating solar. Floating solar is actually the real potential solution in Kerala, because you have 40% of land area, 40% of water bodies in Kerala, mostly around 27 backwaters and reservoir, around more than 50 reservoir dams. So if you combine this floating solar with the BESS, that will be a wonderful solution. Wind, you have based on MNRE potential. I'm looking at 100 meter hub height only. To install a wind turbine with a 100-meter hub height, so that your nacelle of that wind turbine is 100 meter. Okay. You have machines with more than 120 meters hub height. You have in India itself, you have a 5 megawatt machine. Even your 1.5 megawatt, 1.8 megawatt machine will have a hub height of 100 meters. So more than 100 meter hub height machines, larger or more than 100 megawatt, 1.5 megawatt machines can bring big, good results, getting more CUF, capacity utilization factor or plant load factors. So it's important that if you increase the size of the wind machine, you will get more results, more generation. So if you look at the resources of the MISO, what you call the study done by Nive, micro MISO scale study, actually based on some of the wind turbine, wind resource assessment At the ground level, they blended with the satellite-based measurements. They found that we have 1,700 megawatt, and wasteland we have only 300 megawatt, 333. And you have cultivable land 1,000 megawatt. So if you want to install more wind energy, you have to utilize the cultivable land. That's very important. Or you have to cultivate in between. And you have potential in some of the areas. I would say that Pulmed, you know, Pulmed is near to the Pachimed or Sabarimala. Pulmed is known to us because of an accident years back. So Pulmed, there is no trees there, but you have tremendous wind speed. But it is a forest land. You have to have permission for installing wind turbines. So this is the picture. If you look at the wind at less by Nivea, you could see the red. You can see this the speed. What you call the speed is tremendous. You have tremendous speed in areas in Tamil Nadu, but our areas are all on the very difficult areas on the mountains. So it's difficult to erect or difficult to take machines to that area, or especially the blades. So if you want to transport a 1 megawatt or 1.5 megawatt wind turbine, if it is the radius of the, or if the blade radius is something around 50 meters, how can you transport? So you have to utilize military to air picket through helicopters. There is no other way. You cannot go through the airplanes. That is a big challenge. So if you ask me, the biggest challenge is logistical. The second is resource. You have to have resource, at least 1 year data on board to go with the installations. So we have higher wind speeds in Agali and Ramakalmed, Idiki, Agali in Palakkad, Ramakalmed, Nedungandam, Panchalimed, Parindambara, these areas are in Idiki. See the terrific potential in Tamil Nadu. They already reached this class A sites. They reached and more than 8,500 megawatts. So this is Agali, and sorry, this is Ramakalmed area. This is area. This is Idiki. This is Idiki. So this is completely Walayar, what you call that gut region, Walayar and Agali area of Palakkad. This is Palakkad, and this is Idiki, the Ramakalmed belt, Ramakalmed, Pushpagandam, and this is, we have some wind turbines there. This is the area, actually the other pass. This pass is Walayar pass. This pass is Chengota pass. The pass, you know, because the wind, once you the funnel effect, no, if you make the energy skews through a funnel, then you have increased wind potential there, higher wind power density. So that is the phenomena you can see here. So the benefit from the funnel effect is mostly taken by Tamil Nadu, and this is our what you call Chengovil, Chengota, and this is the Ponmudi area. Okay. And I took some areas just for your understanding. In Kollam also we have Chengovil, Chengota area, which is not explored much. Ponmudi also, we don't have bigger wind turbines. And I have seen that Agastyagodam Valley is also having higher wind speed. And all this Idiki area, you know. And I cannot stop this presentation without telling about the world's first 100% solar powered airport. They have all solutions. They started from rooftop. They have a total 40 megawatt installation capacity planned there. And it's a captive utilizing the power to the power needs of their airport, They have man-made floating solar power plants as well. So 71.275 is our megawatt capacity. This is a site from Ramakalmed. Okay, I'm not going much into. I already told the potential of floating solar. This is important just to understand that 92 megawatt floating solar, one of the biggest plant in Palakkad, sorry, at Kayankulam. You know about the NTPC naphtha-based plant. It's not working currently because of the scarcity of naphtha and very higher cost. So LCO will be very high. So 92 megawatt, they diversified it. National Thermal Power Corporation has diversified it. They utilized their own area of water body available. Then why can't we? And they generated 92 megawatts. They used the 450 acre LAC area adjacent to the NTPC. They have, and this is actually the Banasura Sagar Dam, the first installed by KCVL, 500 megawatt, years back. This is on ferrocement platform. This is more MDPI kind of polymer-based platform. More good for getting the temperature down to get the advantage. You all know, you must know that the basic degradation or basic loss is because of temperature loss happening, because the solar modules will have a negative temperature coefficient resistance. Your PV module will have bigger loss, up to 10% is happening because the highest temperature happening on the floating, on the solar modules, when because your STC conditions, standard test conditions are 25 degrees centigrade at the back surface module temperature, 1000 watt per meter square and 1.5 air mass, atmospheric condition. So 25 degrees centigrade is a European condition. So our ambient temperature is 30 degrees centigrade. Then once you expose your PV module into our atmosphere, your module back surface temperature will be around plus 20. So it will be around 45 degree, which can make a loss of 10 to 12% to your PV module, which can be addressed to little bit using a floating solar power plant. Okay, I'm not going much into the technology and all because the time limit. And you have a lot of environmental benefits. This is also I installed a plant at Thrissur as part of the consultancy project 7 years back. Even if you install a small mid-roof, this is a 200 kilowatts plant, you will get a GHG reduction of greenhouse gas reduction of 340 tons of carbon dioxide. It's equivalent to a lot of figures. So that much of environmental impact we are making. I told you about some projects, agri-photovoltaics and all. You can have different solutions as highway rooftops. This is a RAM rooftop by KCB. This is actually in Gujarat, based on a what you call canal top. Of course, for the green hydrogen, you need a lot of renewable power. Muttathara Engineering College is very famous because of their hydrogen mission and their innovation on hydrogen. I know a lot of faculties well known about hydrogen projects and all. They represent the states internationally for it. So hydrogen, if you make a green hydrogen project, I have seen a green hydrogen project at National Institute of Solar Energy, NICE, New Delhi. They are powering from a 150 kilowatt solar. So they have a electrolyzer imported from Austria, I think. It's a KOH based, alkaline based electrolyzer. So if you want to make a green hydrogen, of course, solar and wind is very important because of my topic is that. Solar and wind is predominantly should lead the powering of your electrolyzer. You are going to. So how you find solar? Of course, floating is the best solution, I would say, if you want to go for higher units of hydrogen generation. Okay, I'm not. I'm concluding with this, which I use this slide always about donut economics. Donut is actually donut economics is a economic model predicted by Kate Rawat. She is working currently in UK. She predicted an ideal state where you have an ideal state between dominant, which represents the ideal states where you have good habitation, good food, you have zero ocean acidification, zero chemical pollution. So you are preventing the overshoots of freshwater withdrawal, land conversions, ozone layer depletion, climate change, and you have an ideal state. But you should have an energy independence. So renewable energy is the best thing. Solar and wind is the best thing to look at it. Thank you so much for listening to me. Thank you. And open to questions.
Questions, please, from the audience side.
Good evening, Ajith sir.
Good evening. Good evening.
Sir, I have a question. Sir, the most popular solar capturing technology is based on flat solar panels. My question is, does non-flat solar panels like a dish type solar panel and a solar tree, does it have prospects in Kerala or in general in the near future?
Sudhir sir, actually, dish type you are meaning about the thermal side, right? The dish projector, dish type, and the
no, sir. SPV
only. Okay.
Yeah.
SPV, if you make it as a dish, there will be issues because it's like you are capturing area limits. Of course, there will be limitation. So when you make different kind of even the south orientation with the tilt of equal to the latitude is the best option. If you look at various papers and all journal papers. So as a compromise, you can have a tilt at equal to the latitude. For example, for Hyderabad, you can have a tilt of 15 degree. In Ahmedabad, you can make a tilt of 22 degree. So if you make different tilt and different kind of ups and downs, which of course will affect the total generation. And regarding the solar tree is actually looks beautiful. I have seen a plant in Gujarat like that, and I've seen a small one at Malaysia where I did my PhD as part of their lab experiment. I have seen another one in Dubai. So it looks crazy, but it won't make much of your results. So it can be crazy, but it's an innovation. You can study on it. But don't expect that you will get better results.
Okay, sir. Thank you for the insight, sir.
Yeah, thank you.
Yeah, sure, sir. Thank you, sir.
A lot of myth is also there on the wind energy, I would say. So wind energy is possible unless and until you don't have data. You have data, you cannot generate wind energy because the data is very important to go for higher energy, higher wind turbines. And regarding small wind energy, small wind is actually, it can perform. Small wind, you have vertical wind turbines and horizontal axis turbines. I have seen a news clip today in Hindu. So important thing is your horizontal axis turbine will be more efficient than a vertical axis turbine. Small wind. I have a slide there, but I couldn't show you because of the time limits. So wind is very seasonal, I would say, and with a very high speed gust winds, your machine can come down, especially the small wind turbine. So basically, you cannot, if you go for a solar wind hybridization, of course it can complain a little bit. So don't believe that your wind can completely power your home solutions. Generally, in areas where there is no wind, the average wind speed in Trivandrum is something around at the airport is less than 2 meters per second, which won't trigger your small wind. Your small wind should start with a cut-in speed. The cut-in speed is around 2.5 to 3 meters per second if it is horizontal axis. So I did the sectoral study back in 2005, 2007 for small wind. So the business is not happening actually because of these limitations. It's not happening. because the small wind can function for some time, then because of some gust wind it can came down. It will come down and it will fill. So vertical axis is no exception. It will have the same experience, unless and until it is very rugged. So for me, I would say that the generation, if you look at the power mix of what is happening in a solar wind hybrid station, the power mix, if you look at the power mix output, the wind is contributing very, very little. So, so I would say that you go with the solar because we have enough solar energy. And if you are crazy and you as an academic, for academics, I would recommend to have a study on this. You can have different configurations of small wind turbines, and we can have a small wind hybrid system studies as part of your research, and guiding students, PhD students, as part of your college research work and all. The coastal belt also, we had some measurement done by ANERT. The coastal wind speed is not as much so that we can go with a very higher commercial wind turbine. Only based on the known data, we are very confident that certain areas of Palakkad and certain areas of, especially most Idukki district, are very high wind potential areas. And of course, the areas in, I told you some of the areas in Ponmudi, in Trivandrum, good potential, and some areas near to the Chengota Pass, which is our area is actually Achan Kovil, that part. So need explorations. Without learnings, without data, no corporations will entertain you for installing wind turbines, especially commercial wind turbines. It's very important. Please ask question. Reason, can you see the reason why the much appreciated CL solar energy model is not much similar? It's widely known to the whole world. Only upset was 2018 flood, but because of the they could actually, what you call, some of the repairs they have done intelligently, and they could overcome this the challenge of 2018 flood. Otherwise, I would say that the CL model has been copied by various countries, I would say. I will give an example of Brazil. I have to look at search it. I think it is Rio de Janeiro or Sao Paulo. I feel like it's Rio de Janeiro. There is a bigger solar power plant which contributes the total energy needs of the airport. So it's a great model. I would say that to appreciate CL, they started with 1 megawatt rooftop, then they again started building different utility scale power plants. I remember the days they invited me for a 14 megawatt bill of material checking and equipment checking because MNRE was insisting on that. So the nodal agency should check it. So as part of the nodal agency, I was deputed to check it. So I went there and actually did this checking when it was 14 megawatt only. Now they reached to 40 megawatt. It consists of rooftop power plants, carport power plants, where excellent model where you can use carports. So any solutions you explore with the solar, all are there. You have carports or carport solar, you have rooftop solar, you have ground mounted solar, and you have floating solar. Hope I answered your question. Yeah, I was looking at Brazil. The airport is Salvador Bahia Airport, which is considered Salvador Bahia Airport, which is considered the most sustainable airport in the country. So it's like it's actually it came after our plant only. After the plant happened in, they have 11,000 solar panels. After the CL based plant, this Brazil airport also came. A lot of airports are copying. There is a limitation to it. Just to give an example to the researchers here. One of my PhD colleagues, PhD researchers colleague, Dr. Srinath, he's currently doing a PDF in Europe after his PhD. His papers are predominantly on airport solar. Srinath Sukumaran, you can search on Google Scholar. But he has done a lot of findings on the airport solar, especially on the glares. So there is limitation for glares because glares actually affecting the flights. So there should be a glare study. So one of the purpose he did a glare study. So that's also important. Another question is, sir, is there any solar panel design which can be used within the walls where Central University is low? Yes, it's called BIPV, Building Integrated PV. You can have a lot of designs coming where it can be embedded with the ground, especially the thin film can be, thin film is generally based upon if you spray it on a substrate. So the facades and the walls can be painted with the solar material, photovoltaic material. Otherwise, even your traditional crystalline silicon solar modules can be utilized with there are kind of modules where you don't have frames. Frameless modules are there, where it can be blended to your walls. So it's based upon you cannot completely depend upon and trust that it will generate like your ground mounted solar, but of course it will have a contribution. So if you look at, it's called a BIPV. So BIPV, there is a research going on in NIST also. So BIPV is building integrated PV. So you can integrate your building with the PV. It can be rooftop, it can be on facades, it can be on your windows, you can be on different areas. So where you cannot completely orient your solar panel towards south and all, to orient in different direction, only thing is there will be a reduction in generation. But it can be a powerhouse. Yes. I think I hope I answered it. Of course, the sun intensity is low when you make it vertical to the sun, what you call it. So at some point of time only you will get maximum energy. But in this kind of areas where you have you can have what you call certain areas where you can have you can erect your bifacial with a white background to get more reflection and getting more energy generation. A BIPV, building integrated powerhouse, or building integrated PV based house with an EV charging station is an excellent example where you can have you're powering your own home and utilize the power. Even with your solar rooftop, you can do it. The BIPV is a bit more expenditure on your side because some of the wastage will come. Yeah. Thank you, Sunish.
Thank you, sir. Thank you for a wonderful session. And your session given an audience a deep understanding of various solar and wind energy systems and the solution for a sustainable future and a clean energy. So thank you, sir. Thank you for the session.
Thank you so much from the wholehearted support from the whole team, Muttatara Engineering College, and the whole FDP team. It's a privilege to be here with all of you, with all the knowledgeable faculty. I hope enjoyed my lecture, and I try to interact, but see, there is limitation for our online sessions. But you can reach me, Ajith Gopi at IEEE.org. Yeah. Thank you so much.